Next results. If the two circles x square plus y square plus 2gx plus 2fy plus c equal to 0 and x square plus y square plus 2g1x plus 2f1y plus c1 equal to 0 are intersecting at two distinct points, then x square plus y square plus 2gx plus 2fy plus c minus x square plus y square plus 2g1 plus 2f1y plus c1 equal to 0 are that is first circle minus second circle, right? So if you are subtracting, the x square y square term will go, because you are subtracting x square minus x square y square minus square. So remaining terms you can group x, y and constant term. So 2g minus g1x plus 2f minus f1y plus c minus c1 equal to 0 you will get, right? Which represents a common chord of the circle, right? So you can easily find the common chord, first circle minus second circle, then you will get the common chord if the two circles are intersecting, right? So given circles are, we'll see the proof. So first circle, right, x square plus y square plus 2gx plus 2fy plus c equal to 0, and the second circle x square plus y square plus 2g1x plus 2f1y plus c1 equal to 0. Let p x1y1 and q x2y2 be the point of intersection of 1 and 2, right? So these are the point of intersection. Since p x1y1 lie is on both 1 and 2, p x1y1 satisfy both 1 and 2. So put x is equal to x1 and y is equal to y1 in both 1 and 2. So 1 implies x1 square plus y1 square plus 2gx1 plus 2fy1 equal to plus c equal to 0. That is equation number 3. So 2 implies x1 square plus y1 square plus 2g1x1 plus 2f1y1 plus c1 equal to 0. That is equation number 4. Since q x2y2 lies on both 1 and 2, so q x2y2 satisfy both 1 and 2. So put x is equal to x2 and y is equal to y2 in 1 and 2, right? So 1 implies x2 square plus y2 square plus 2gx2 plus 2fy2 plus c equal to 0. That is equation number 5. 2 implies x2 square plus y2 square plus 2g1x2 plus 2f1y2 plus c1 equal to 0. That is equation number 6. Now 1 minus 2 implies x square plus y square plus 2gx plus 2fy plus c minus x square plus y square plus 2g1x plus 2f1y plus c1 equal to 0. That implies, so just you are removing the bracket and simplifying. X square minus x square get cancelled, y square minus y square get cancelled. So remaining term 2gx plus 2fy plus c minus 2g1x minus 2fy minus c1 equal to 0, right? So grouping x term 2 common g minus g1 into x plus 2 common y term grouping, right? F minus f1 into y plus c minus c1 equal to 0. That is equation number 7. Clearly 7 is the linear equation in x and y which represents a straight line, right? So 3 minus 4, that is x1 square plus y1 square minus plus 2gx1 plus 2fy1 plus c minus x1 square plus y1 square plus 2g1x1 plus 2f1y1 plus c1 equal to 0. So you will get 2g minus g1x1 plus 2f minus f1y1 plus c minus c1 equal to 0. That is equation number 8. Similarly 5 minus 6 you will get 2g minus g1 into x2 plus 2f minus f1y2 plus c minus c1 equal to 0. That is equation number 9. So 8 and 9, from 8 and it is clear that the point x1 y1, p x1 y1 and q x2 y2 satisfy equation 7, right? Hence the equation 7 represents a line passes through p and q, which is the common chord of the circle 1 and 2, right? Next result, if two circles, the same circle x square plus y square plus 2gx plus 2fy plus c equal to 0 and x square plus y square plus 2g1x plus 2f1y plus c1 equal to 0 are touching each other, then first circle minus second circle equal to 0, right? Or so when you are subtracting you will get this term. I already explained to you, right? 2g minus g1x plus 2f minus f1y plus c minus c1 equal to 0, right? In the previous case, the two circles are intersecting at 2 points. Then this line represents a common chord. But in this case, they are just touching each other. That means point of intersection is a single point. Then in this case, this line represents a common tangent of the circle, right? That is the difference, right? We'll see the proof like above, right? Given circle, first circle and the second circle, right? So Px1 y1 be the point of contact of 1 and 2 because they are touching each other, right? Like this. Let C1 C2 be the center of 1 and 2 respectively. So C1 is minus G minus F and C2 is minus G1 minus F1, right? Now 1 minus 2 will gives you, so x square plus y square plus 2gx plus 2fy plus c minus x square minus y square minus 2g1x minus 2fy minus c1 equal to 0. So grouping x term, y term and constant term, you will get 2g minus g1x plus 2f minus f1y plus c minus c1 equal to 0. That is equation number 3. Clearly 3 is a linear equation in x and y, represents a straight line, right? So this is the straight line. Now see, this is the straight line passes through Px1 y1. The slope of 3 is m1, which is equal to minus 2 into g minus g1 by 2 into f minus f1. So we know ax plus by plus c equal to 0. Slope of the line is minus a by b, coefficient of x by coefficient of y. So we are using that formula. So 2 and 2 get cancelled, minus g minus g1 divided by f minus f1, right? So that is equation number 4. Now slope of the line joining C1 C2 is, we know C1 and C2, right, centers. First one is minus g minus f, second C2 is minus g1 minus f1. So we are using 2-point form, slope, right? y2 minus y1 by x2 minus x1, right? So you will get minus f1 minus f minus g1 minus g, right? Minus of minus g. So f minus f1, g minus g1, right? So this is equation number 5. So first slope is slope of 3 m1 and slope of the line joining c1 c2 is m2. So we are going to take the product of m1 and m2. m1 into m2 is equal to minus g by g1 minus g minus g1 by f minus f1 into f minus f1 in by g minus g1. So g minus g1, denominator g minus g1 get cancelled, numerator f minus f1, denominator f minus f1 get cancelled, you will get minus 1. So product of two line, right? Product of the slope of two lines, which is equal to minus 1, then those two lines are mutually perpendicular. We know the result, so we are going to use that result. Therefore the line 3 is perpendicular to the line joining c1 c2. Also the point Px1 y1 satisfy equation 3. Therefore 3 represents a line which is the common tangent of 1 and 2. Thanks.